third unit, first topic, that is context-free grammars here. Okay, as I already told you, the tree-like structure there. So there you will find the context-free grammars. So what is meant by context-free grammar is, so what is grammar? So grammar is said to be here, G is a grammar. If you think G is a grammar, then every production should be in the form of alpha tends to beta. Okay, where alpha and beta are the LHS and RHS here. Okay, so alpha tends to beta should satisfy the following rules. So in that, first rule will be the LHS only contains the non-terminals, where RHS can be anything. That can be a mixture of non-terminals and the terminals. Okay, so here first rule in this is LHS only contains non-terminals. RHS can contain anything that may be the non-terminals and the terminals. So here this context-free grammar is denoted by the symbol G here. So let us take the context-free grammar is G, and it contains 4 tuple notations. As I already told you, in the finite automata, you'll be having the 5 tuples. So whereas coming to the context-free grammars, you will be having the 4 tuples. Okay. So what are those 4 tuples is V, T, P, and S. So what is meant by V here is nothing but the set of variables, or the non-terminals, we can say. Okay, so set of variables are the non-terminals. Non-terminals belongs to LHS. Okay, so where alpha tends to beta is nothing but it is a context-free grammar. If it is in the form of alpha tends to beta, where alpha is the LHS and beta is the RHS here. Alpha is nothing but set of the non-terminals and beta is nothing but anything that may be the non-terminals and terminals. So here V is a set of variables or the non-terminals here, and T is a set of terminals, and S is a starting symbol of the grammar, and P is a set of finite number of productions. Set of finite number of productions are the rules, we can say here. Okay, so what is meant by V? It is nothing but a set of non-terminals. So let me take a simple example and tell you what are V, T, S, and P. Okay, so what is V here? V is nothing but set of variables or the non-terminals, I told you, no? So here I am taking the example. So E tends to E plus T by T. Okay, so here T tends to F. F tends to ID. Okay, so here in the above example what I have taken, so the context-free grammar is nothing but the set of 4 tuple notations, I told you, no? So in that 4 tuple notations, V, T, P, and S are the 4 tuple notations I told you. So first let me take V. What is meant by V? It is nothing but set of non-terminals. Set of non-terminals. So here non-terminals are nothing but, I told you alpha tends to beta is nothing but the context-free grammar means alpha is the LHS. LHS is nothing but here set of non-terminals. So LHS is here E, T, and F belongs to the LHS here. These are the non-terminals. And coming to T, what is meant by T here? It is nothing but the set of terminals. It is nothing but the set of terminals here. So what is set of terminals we are having here? Plus, ID, hash, all these belongs to the terminals here. Okay, and yes, what is yes? Yes is nothing but the starting symbol of the grammar. S is nothing but the starting symbol of the grammar. What is the starting symbol of this particular grammar here? What is the starting symbol of this particular grammar here? That is E. Okay, E tends to E plus T by T, I told you, no? So that will be the starting symbol of the grammar. Okay, and then P is nothing but the set of finite number of productions. So what are the productions we are having? We'll write all those productions here. That is E tends to E plus T, E tends to T, and T tends to F, and T tends uh, T tends to F and F tends to ID. All these are the finite number of productions we are having. So that will be the P here. Okay. And after this, so what I told you in the CFG, in the context free grammars, we'll be having four number of tuples, four tuple notations will be there. And in that, V is nothing but the set of variables and the non-terminals. So in this example, I told you E and T, E, T and F are the non-terminals, and T will be the set of terminals. I told you that will be plus ID, ash. All these are the non-terminals, sorry, terminals we are having here. And S is the starting symbol of the grammar. E in this grammar, E is the starting symbol. So I have given it as yes. And P is nothing but the set of finite number of productions or the rules we are having here. So in this, that is nothing but the context-free grammar. That is nothing but the context-free grammar. And then here we are going to use the derivations using the context-free grammar. Okay. So what is meant by a derivation is nothing but it is a step-by-step process where we are going to replace the non-terminals with the appropriate productions here. So we are going to replace each and every non-terminal here. Okay. So there will be two types of derivations here, leftmost derivation and the rightmost derivation. Okay. What is meant by leftmost derivation? Is nothing but from the left side, non-terminal is replaced with the production. Okay. From the left side, we are going to start the replacing of the productions here. So in each and every step of the derivation, leftmost non-terminal is replaced with the production here. Okay, so that is nothing but the leftmost derivation. So if I take this particular example here, what is the example I am taking is E tends to E plus T by T. So let me do this particular example in the whiteboard so that you can clearly understand how to do the leftmost derivation. Let me explain you in the whiteboard so that you can clearly understand this example, how to do the leftmost derivation. So I'm taking the example as E See here, I am taking the example as E is equal to E tends to E plus T by T. Better I will explain with this PDF now. After that I'll do. See here, it is E tends to E plus T by T and T tends to T into F by F and F tends to E by ID. Okay, so here leftmost derivation I am going to do. So I am taking it as E tends to E plus T. Okay, so that is I am going to substitute in place of E tends to E plus T I am taking now. And then what I am going to do in place of E, I can substitute T also here. Okay, I can substitute T also here because E tends to T also. Okay, so I am taking it as E tends to T here. And after that, in place of T, I can also substitute F. So that is F plus T. What I have to do is I have to derive ID plus ID into ID. Okay, so that is the format I have to derive. So for that I have to substitute T tends to F. Okay, in place of T. And after that, in place of F, I can substitute as ID. Okay, so that is what I am going to do. F tends to ID. And after that, what I am doing in place of T again, I am substituting T into F. I am substituting T into F. Okay, so that is T tends to T into F. I am substituting. So after that, in place of T, I can also substitute F. Okay, so F into F. In place of T, I am substituting T tends to F here. So in place of F, I can substitute ID. So F tends to ID. In place of F, I can substitute ID. F tends to ID. So is this in the format of ID plus ID into star? Yes, now. Okay. So that is what leftmost derivation. Leftmost derivation. Okay. From the left side, we are going to replace all the non-terminals here. Okay, and also we are going to derive what is the string we want. What is the string we want here? ID plus ID into ID here. So that is what we want. So for that, what are the minimum number of productions we are going to get? That many productions we are going to take. We are not going to make it as a lengthy production here. Okay, so coming to the next derivation, that is rightmost derivation. So as I told you, two types of derivations will be there, leftmost derivation and also the rightmost derivation. So in this rightmost derivation, what we are going to do is, in each and every step of the derivation, rightmost non-terminal is replaced with the production. From the right hand side, we are going to replace all the productions here. So the number of productions should be reduced whenever you are going to take the string. The number of productions should be minimum. You are not going to make it as a complicated. Okay, so consider the same example what we have taken for the leftmost derivation. So what is the example I have taken? The same example I am doing with this ID plus ID into ID. Okay, so that is the what I have to derive the string by using the rightmost derivation. So rightmost derivation means from the right hand side you have to move. From the right hand side we are going to move here. Okay, so here see, from the rightmost side we are going to do. So here E plus T is first. I am going to take the production as E tends to E plus T. Okay, so in place of E, I am substituting E tends to E plus T. And after that, what I have to do from the right hand side, I have to derive. No. So from the right hand side means this side. I have to derive from this side. So that is T into F. In place of T, I am replacing T into F here. So, and after that, what I am going to do? After that, I am going to do, that is, in place of F, I am going to substitute. In place of F, I am going to substitute ID here. Okay, so that is ID. Okay, and after that, what I am going to do? So in place of T, what I have to substitute? ID. Sorry, in place of T, what I have to substitute? F. So that is what we have done here. So F I have substituted. T tends to F. So now what I have to do in place of E, F tends to ID I have substituted here, and after that in place of E I have to substitute T. Why you can't substitute E plus T? Yes, you can substitute, but what is that is the productions will be complicated again. You have to reduce more. So what you have to do is in this ID plus ID into ID you have to take. ID plus ID into ID you have to take. So for that, what are the minimum number of productions you have to take? You can take that minimum number of productions. So that is E tends to T. Okay. So that is in place of E, you are substituting T. And after that, what you are going to do is in place of T, you have to substitute F simply. Okay. So I'm substituting F here. So after that, what you have to do? ID plus ID into ID. ID plus ID in place of F, I have substituted ID. So what is the format I am going to get here? ID plus ID into ID here. So that's what we have done or not? Yes. Okay. So here we have derived the rightmost derivation. We have derived the rightmost derivation here. So that is the derivations we are having. That is the derivations we are having in the context-free grammar. What are the derivations we are having? Two types of derivations we are having, leftmost and the rightmost. What is leftmost? From the left hand side, we are going to replace the non-terminals. Whereas rightmost means from the right hand side, you are going to replace the non-terminals. Okay. So that is rightmost derivation. And coming to this next one, so the language of grammars will be the next topic here. So what is that language of grammars means? Every grammar will generate a language here. So every grammar, that may be the regular grammar or the context-free grammar or the context-sensitive grammar, every grammar is going to generate the languages. So the regular grammar will generate the regular languages and the context-free grammars will generate the context-free languages here. So here, what is the language generated by the grammar is nothing but the strings accepted by the grammar here. So the language is nothing but the number of strings accepted by that particular grammar. Okay. So here the strings can be accepted, or the string is a member of that grammar, can be analyzed in two ways here. Whereas what are that particular two ways? It is derivation and parse tree. So here, how can you tell that the language is accepted by the grammar? The language generated by the grammar is nothing but the strings accepted by the grammar, I told you, no? So that is acceptance of the string. So in the finite automata, I told you how to accept the string here. When you go when you go from initial state to the final state, okay, with that particular string, then that particular string will be accepted by the finite automata. Okay, so here also in this context-free grammar also the strings can be accepted. How can you say the acceptance of the string? That can be in two ways, that is derivation and the parse tree. Okay, so in the derivation, I already told you in the derivation, that is leftmost derivation and the rightmost derivation. As already we have done with the leftmost derivation and also the rightmost derivation. How to derive from the left side and how to derive from the right side with the same string. Okay, so if you derive that particular string with that particular context-free grammar, then we can say the string will be accepted. So in the previous example, what I told you the string is ID plus ID into ID. So that particular string we have derived or not? Yes, we have derived. So that means that particular string will be accepted by the context-free grammar here. Okay. So in this, already I told you that in this two ways will be there. One is the derivation, another one is the parse tree. So what is meant by parse tree? What is meant by parse tree? That is nothing but it is also known as the syntax tree, or it is also known as the derivation tree here. Okay, we can also say this parse tree as a syntax tree and also the derivation tree. So as I have already mentioned, tree is nothing but here it is a hierarchical representation of the derivation. It is a hierarchical representation. Always the tree will be in a hierarchical representation, as you already studied in the data structures. What is meant by a tree? So it is nothing but a hierarchical representation. So what it consists of? It consists of root, starting, and also the non-terminals. Okay, so it also consists of leaves. So what is a root here? That will be the starting, or that may be the non-terminal. Okay, so that will be the starting node, or that will be the non-terminal. What is meant by leaf? Leaves, all the leaves are the terminals. All the leaves are the terminals. So what is internals and non-internals here? Non-internals are nothing but non-terminals here again. Okay, so internally if you are going to have any nodes here, so that will be the non-terminals. So as I told you, what it consists of? This parts tree consists of root, leaf, and the internals. What is meant by root? Root is the starting, okay, or the non-terminal, we can say. Leaf is nothing but terminals. Internals are nothing but non-terminals. Okay, so again, now I am taking an example that string, I have to derive that particular string id plus id into id. What is the example I am taking here is, what is the example I am taking? The same example what I have taken previously. The same example what I have taken previously. What is that example I have taken? E tends to E plus T by T, and T tends to T into F by F, and F tends to E by ID. What is the example I have taken for the leftmost derivation and the rightmost derivation? The same example I am taking here. Okay, for the parse tree also. For the parse tree also, the same example I am taking here. Okay. See here. So the same example means, see, E tends to E plus T. First I have to take that. That is the leftmost derivation. Okay. So what I have to do, from the left side, we are going to derive. From the left side, we are going to derive here. E tends to E plus T. What is E here again? We can say E as T also. And again we can replace this T as F, and we can replace this F as ID. Okay. So first I can take, in place of T, in place of E, I can take T, and in place of T, I can take F, and in place of F, I can take ID. So here plus is nothing but, here plus is nothing but the terminal. You are not going to replace all the terminals here. Okay, so plus is nothing but the terminal. So the same way we are going to drop it down. And next what we are going to do, in place of T, what I can replace here? In place of T, I can replace T into F, because I have to get the string as ID plus ID into ID, so that you have to get into mark compulsory. So for that I have to take T into F. So here T means, here again you can replace the T as F, and F can be replaced as ID again. Okay, so here into is the into is the terminal, so we are going to push it down here, and after that F is the tends to ID here, so we are going to replace with the ID. So what is the format we are going to get is ID plus ID into ID. That is a leftmost derivation parse tree. Okay, so coming to this rightmost derivation parse tree, E plus T. From the right side you are going to do, from this side. From this side you are going to do. So that is T into F. Okay, So what is T? In place of T, I am replacing it as T into F. So what is F here? F is nothing but F tends to ID. What is T here? T tends to F. F tends to ID. Again, I am replacing in place of T, I am replacing it as F. In place of F, again, I am replacing it as ID here. Okay. So this particular star is a terminal. So the same thing I am dropping down here. And then in place of E, I am replacing T. Again, in place of T, I am replacing F. And in place of F, I am replacing it as ID here. Okay, so that is ID plus ID into ID. ID plus ID into ID. So whether we are getting the same thing or not? Yes. So what we are going to do that is, so the same parse tree we are going to get for this particular leftmost derivation and the rightmost derivation also. See here, the same parse tree we are going to get. Okay, so that is ID plus ID into ID. If you are going to derive that particular string, ID plus ID into ID, the same parse tree we are going to get. It is not compulsory that for each and every string we are going to get the same parse tree, but this particular string we are getting the same parse tree here. Okay, so that is the that is what we are having here. Okay, so derivations and the parse trees. So in the language of context free grammars, we'll be having the derivation and the parse trees. Okay, so here that's what I am going, I thought of discussing in this particular session here. So the language of the grammar I have discussed. The language of the grammar is nothing but the acceptance of the string. The acceptance of the string will be in two ways here. So that is derivation and the parse tree. Derivation means the leftmost and the rightmost derivation. Parse tree, in the parse tree also again we are going to have the leftmost and the rightmost here. Okay, so that's what I thought of discussing now.